everyone, this is Spuggyhawk and welcome to another episode of Turtle Time. At the end of the last episode we had a miner program that would dig out a 3x2 tunnel 64 blocks long. In this episode we'll adjust and improve on that program. First I'd like to change the way it places torches. At the moment it simply digs a hole and places a torch. If there's water or lava behind that hole it will wipe out the torch and flood into the tunnel. To fix this we should move into the hole that we've dug and make sure that there will be blocks surrounding the hole. We already have the functions in place to do that. Our forward function will ensure that we deal with any gravel and then move into the space. Once we're in the space, the check functions can be called to fill in any holes. After any potential holes are filled, we can back out of the space, place the torch, and then continue with the mining. Let's see how that deals with a couple of holes that open into a cavern. That's sealed up the tunnel nicely and will prevent anything from getting in. Next, I'd like to add a bit of tidying up by getting the miner to dump its cargo into a chest if one's available. This is very similar to code that we've seen before. After getting back into the starting position, we'll turn around, check to see if there's anything there, and if there is, we'll assume it's a chest and dump everything from slots 4 to 16 into it. Then turn around again. The detect function just tells us that there's a block of some sort in the way. I'll leave it up to you to improve that code to see if it's a chest. If you have any difficulty with that, just leave a comment and I'll be happy to help. As you can see with the redstone here, where a tunnel digs through a seam of minerals, there's quite a high probability that it will miss some because of the blocks that will be left in the walls, floor or ceiling. We already have the check functions that are looking for holes around the tunnel, and we can expand those functions to have a look at what blocks are in the tunnel walls and decide whether we want to dig them out. If the inspect function succeeds, then the data it returns will contain the name of the block in data.name. We can write another function called collectThis and pass in the name of the block. CollectThis can check the name and return true if we should dig it out and false if we don't need to. For example, if it's just stone. Each of the check functions needs to be updated separately because of the different inspect and dig functions that we use. However, the checking of the block itself is the same each time, so that can be separated out into a function of its own. That way we don't need to write identical code 3 times. The collectThis function will receive the block name as a string. It needs to either return true or false depending on whether we want the block or not. We'll start by setting the default result to false, which means that we don't want the block. Then we can check the name of the block that was provided, and if we find a match for something we want, then we can change the result value to true. Because I only have the ComputerCraft mod in this build of Minecraft, all the blocks that we inspect will always start with the text Minecraft : We can start with a test for gold. If the name of the block is Minecraft : gold_ore, then we want to dig that out, so we set the result to true. but we want to check for more than just gold. Let's expand the test to check for gold or iron. In this case, that would be Minecraft:iron_ore. Okay, but what else do we want to check for? Redstone for one. I wasn't sure what the name would be for redstone, so let's move the turtle so that it's over the block and then write a quick program to find out. As before, we'll get the success value and data values from the inspect down function. In this particular case, it's probably not necessary to check for success, but it's a good idea to make sure that you always write the most solid code you can. Assuming that we are successful, all we need to do is print the value in data.name, and that's Minecraft:redstone_ore. I'll provide a link in the description to list all the standard blocks and their names. In the meantime, let's get this turtle back to where it should be and update the test in the collect this function. Whilst we're here, we might as well add tests for some of the other blocks that we really don't want to miss. Diamond ore and coal ore should be collected too. Okay, well that test contains the text Minecraft: quite a few times. It would make things easier to read if we could just look at the text after the colon. There are a few ways to do this, but the one I'll show you here will use a function from the string API. The Computercraft wiki explains that the string API is basically just the default Lua string API with a couple of functions that don't quite behave as expected. We don't need those yet, so we'll ignore that and go straight to the Lua documentation. There are quite a few functions available here for strings. For example, getting a string length, converting a string to lower or uppercase, or reversing the order of letters in the string. The function we're after is called gsub, or global substitution. The s parameter is the original string, in this case the complete name of the block. The pattern parameter is the text that we want to find within that string. In this case, we're looking for Minecraft:. And the REPL parameter is the text that we want to use to replace the pattern when we find it. We'll replace our pattern with an empty string, effectively deleting it. The last parameter n is optional and we won't be using that here. So let's update the code. We've got the full block name in the function and we're going to shorten that. So I'll create a variable called bname to store the shorter string. gsub is in the string API, so we need to include string dot in front of it. The first parameter is the original block name. The second parameter is the pattern Minecraft:, and the third parameter is an empty string. That's written using inverted commas with nothing between them. bname should now store the name of the block without the Minecraft: prefix. This means that we can check the value of bname against gold ore, redstone ore, etc. That leaves us with a much more readable function. Okay, let's see what that finds in the tunnel. That's collected the redstone ore okay. I'll scarper off down the tunnel and we can see how it copes with some of the other minerals. No problem with iron. It collects the gold correctly. That all looks pretty good to me. And here at the end of its run, you can see the inventory selection stepping through as it empties its inventory into the chest. Next, well, what else can we do to round out the features of our miner? Let's add some code so we can tell the miner how far we want it to tunnel. This will allow us to type -6 for a short tunnel, or -200 if you really want to go nuts. We'll start with a default tunnel length of 16. That way, if no parameter is provided at the command line, we can just tunnel 16 by default. We also need to update the while loop to use that new value of blocks to mine. So far, we've only run the miner program by typing miner at the turtle's command line. If we're going to type miner 24, how do we access that 24 from inside the program? Well, extra parameters typed on the command line are called variable arguments, or var args. It's quite a mouthful, but let's have a look in the Lua manual to see what it can tell us. Here you can see some examples, and the first one we're interested in is the a, b equals ... which is also called an ellipsis. The ... represents all the things that are typed after the word miner on the command line. They're all provided into the program as strings, so a, b equals ... means find the first two things that were typed after miner on the command line. So for example, if you were to type miner space hello space world, in this case A would contain hello and B would contain world. If you were to type miner space hello, A would contain hello and B would be nil. There are other ways to use var args, but for now we'll stick with what we've just learned. So let's look for the first thing typed after the word miner and store this in to mine. Hopefully this will just be a number that says how many blocks we want to mine. If nothing was typed after miner, then the value of to mine will be nil. We need to make sure that this isn't the case before trying to use it. To do that, we'll check if to mine tilde equals nil, where the tilde equals means not equal to. In order to use it as a count value, we have to make sure that it's converted from a string to a number. The Lua documentation has a complete definition of toNumber. And if the miner is going to accept the number of blocks to mine from the command line, then it might be a good idea for unfinished tunnels and things to allow us to type an additional parameter which will be the number of blocks to skip before starting to mine. Just as we did with the blocks to mine, we'll have a default value for the blocks to skip. That default value should be 0 because normally we don't want to skip anything. We'll pick up the value from the command line exactly the same way as we did with toMine. If it's not nil, we'll convert it as before into a number. And then before mining starts, we'll have a loop that moves the turtle forward that many blocks and keeps track of the position as it goes. Now we can dig out a sample tunnel with this. Let's try mining a tunnel 4 blocks deep. That seems to work fine. Let's try mining 2 more blocks at the end of that tunnel. The reason it didn't mine anything is because the first value we provide is the total number of steps the turtle needs to take from the starting position. So to mine 2 further blocks, we need to actually mine 6 with a skip of 4. Here's a little bonus I found by accident. If you right-click on a turtle whilst holding some dye, it colours the turtle. So here are 3 different coloured turtles, all running the same mining program, spaced out along a wall, all digging 32 blocks deep. As you can see, the yellow turtle has mined into a lava pool, but as it's progressing through the lava pool, it's building the walls around it. This means that the lava is being sealed out of the tunnel. And eventually, we have a clear tunnel again. In the tunnel next to it, the red turtle has hit the same lava pool. And you can see here, it's clearing the tunnel of lava as well. If these turtles were using the original tunnel program, all this lava would just stay in the tunnel because nothing would be sealed, and when the turtle had reached the tunnel end, it would just stop. So you would have to find a way to get around all that lava in order to retrieve the turtle. That's all for this episode. Thank you very much for watching. I hope it's been useful. Don't forget to like and subscribe, and I'll see you in the next episode.